Hello, everybody. Chat should be live. So someone could just say, I hear you. That'd be great. um, Make sure this is all set up correctly. All right, I'll get started. Thanks, William. Wanted to make sure. All right, cool. All right, well, let's get started. I've got a lot to cover. Hopefully, this will be beneficial to you all. I'm Ry Walker. I'm the founder and CTO of Astronomer. I'm also a committer on the Airflow project. Today, I'm going to talk about the current state of observability with Airflow. So before we get started, I just want to share a little bit about my company, Astronomer. We've been in business a few years. We've helped hundreds of companies adopt Airflow. We've raised a fair amount of venture capital, and our products at this point are designed to give what we call Airflow dial tone, i.e., a reliable Airflow service. You can run Astronomer software yourself on your own Kubernetes, or it's installed with Terraform and Helm, or you can subscribe to our SaaS platform where we take care of all the DevOps for you. And so we're a remote company. Employees all over the world, currently around 90 people. So we're actively hiring both software and data engineers. And for those of you who might not be super familiar with Airflow, I'll just spend a couple of minutes providing a quick overview. Airflow is used to programmatically create complex workflows using Python, targeting data processing and ML workloads. It's open source under the Apache 2 license. It's a top level project with Apache. It's a very active contributor and user community. Important concept for Airflow is the DAG, Directed Acyclical Graph, which is a non-looping tree of tasks, and I'll explain more of that in a second. But the key thing to know about Airflow, though, is that it's sort of like the opposite of a no-code platform. You can use the full power of Python to meta-program your workflows. You keep all your work in a Git repo, just like other software, and you can use any Python PyPy package or pre-built Airflow module for common tasks. You can also create your own Airflow operators and abstractions that make it easier for your users to do repetitive tasks with Airflow. So basically, here's a DAG. DAG is key idea here is that it can never loop back on itself. All arrows have to go in one direction. And here is a DAG visualized inside of the Airflow UI. Note that when you look at a DAG in Airflow, you can tell what type of task it is by the background color and the status of the task by the color around the border. And so this view updates in real time, so you can sort of watch workflows during development or in production. So an Airflow deployment often contains many DAGs, in some cases thousands. I'll share a little more detail on what's running behind the scenes to make it all possible. And here is a quick screenshot of Airflow, a production instance of Airflow. I took earlier today as an example, Airflow deployment. You can see that it uses the cron tab format to define the recurring schedule for each DAG. That's another important part of Airflow is generally they're on a recurring automated schedule. You can kind of at a glance see all the statuses of successful, running, failed tasks. And there's lots of subviews that I won't go into here, but all those little icons on the right are additional views that you can dig into to introspect what's going on. You can also search the list and filter by tag or by owner. And so the interface can feel pretty intimidating at first, but once you get into real world situations, you realize the purpose of everything that Airflow has inside of it. So let's see. So the Astronomer product is designed to allow you to create, configure, and decommission Airflow deployments. So in this view, I'm nesting tasks inside of DAGs, inside of Airflow deployments, and inside of an Astronomer deployment. The Astronomer deployment runs on Kubernetes. It gives each Airflow deployment its own Kubernetes namespace. And here's a you can create an Airflow deployment programmatically with our GraphQL API via the CLI or through this easy to use web interface. So you can choose like what Airflow version you want to run, what executor to use, how many workers, how much compute you want to give to the web server, the scheduler, etc. So that's the quick overview of Airflow. One final point I might add is that there's a lot of services running. So the blue boxes are services from Airflow itself. The orange boxes here are databases that you have to bring to Airflow in order for it to operate. It needs Postgres and a Redis or RabbitMQ. And then when we're running Airflow inside of the Astronomer platform, we actually fire up additional components to streamline database access, to give you more visibility into the worker queue, and to route metrics and logs to external services. So, but as we all know, like in addition to infrastructure monitoring or observability, there's a lot more that people would like to observe these days. So the Airflow UI does a pretty good job for DAG authors and the data engineers and ML engineers, but there's still a lot to be desired. For example, knowing the progress of a long-running task. You can't really get to that very easily today. Astronomer and Unravel and others have built nice dashboards to watch the infrastructure layer. But I'm going to focus most of my attention in this presentation to what I consider higher level concerns, which I've labeled business here. But really, the concerns cut across all the roles and responsibilities. So let's dive a little deeper into that. And by the way, if you have any questions throughout the presentation, feel free to use the Q&A tab, and I'll probably have some time at the end where we can, dive deeper into anything that's interesting to you. All right. So first, I just want to make sure you know that Airflow has a lot of built-in metrics that are consumable by running a statsd daemon in your deployment. So from there, you can consume those metrics with Fluentd or Datadog's scraper, likely with Unravel at some point here soon. These metrics, they're not comprehensive, but Airflow provides a way for you to define custom metrics alongside the standard ones. And obviously, since this is open source, if you come up with a good new generalized metric, we're always happy to have outside contributions. But it's important to know that there's been a lot of work done to get some basic metrics emitting out of Airflow itself. So let's dig into data quality for a moment. This is a technology we're pretty excited about. Great Expectations. I believe they're speaking at this event as well. But I'll just quickly overview that. It allows you to define data validations. And run those validations at key points in your data pipelines. So to ensure data quality, it also gives you a way to document what your data expectations are. You can also use the output of the validation to generate alerts. And so the Great Expectations team has built an official integration with Airflow that makes it easy to integrate Great Expectations into your DAGs. It's not a magic pill, but Great Expectations makes it really easier to trust that your data pipelines are doing what you expect them to do, and basically programmatically build these checks into your DAGs directly versus, say, having to check some other dashboard while the Airflow processes are running to make sure things are happening that you would expect. So we're pretty excited about Great Expectations, and we have a lot of customers using it. Another pretty interesting tool to us is a company called Databand. It ingests Airflow metadata and allows you to configure alerts based on a number of situations where you might want to be alerted. It has an API where you can send basically inside of your Airflow DAGs, you can send custom data metrics to their service, which can then also be connected to alerts. And the reason why I think this is cool overall is that you can kind of combine those two ideas to simulate internal progress of an Airflow task. So in this example, let's say you expect a long-running task to update a certain table 30 minutes into the task. So you could create an alert here that if you haven't seen an update after it's been running for 45 minutes that you would expect, maybe there's some problem with this long running process and you could dive deeper. And so, again, if this is running every hour or every 6 hours, it's nice to get an email alert earlier than later, so you can jump in and deal with the problems. So again, a lot of observability and Airflow is I consider it sort of disjointed right now because there's lots of different services and ideas that are percolating, and I hope that over the coming year or so that we figure out ways to consolidate this into a more centralized user experience. So let's jump over to data lineage for a moment. I think this is another really important area. Airflow gets criticized as being not data aware. And so I've been spending some time lately learning about data lineage and specifically about Marquez, which provides a data lineage view of Airflow DAGs, ideally automated or with very low effort from the data engineer. That is, what Marquez does is it actually digs into the task definition and figures out, oh, this task is bringing data from this source and sending to that destination, and it actually creates all that metadata automatically, which is pretty cool. And so the normal Airflow DAG, you would see, these little gear icons, this task ran and that task ran, but here it'll basically explode that out and show sources and destinations in the middle. And so the way it's doing that is, there's an integration with Airflow called Marquez Airflow. And like I said, it basically reads, in this case, this is the Postgres operator that they created, a little add-on to it that literally parses the SQL and figures out what the from table and what the schema is of it and so on, and sends that data along with the to the Marquez service, so you can visualize all that stuff. Similarly, maybe some of you are familiar with Apache Atlas, which this is a very similar view to the Marquez view that I just showed. And there have been people who've integrated Atlas with Airflow as well to get the same idea. Now, Atlas is a bit heavier of a solution, and so there's some people that are reticent to attack it based on that. But again, there's actually been some work in Airflow itself to provide support for Atlas. So there's actually a way to add inlets and outlets to your tasks in Airflow that then behind the scenes, it'll push that lineage into XCOM, and then you can define a backend service, i.e. Atlas, to consume, to basically pull that metadata out down into Atlas. So it's considered an experimental feature right now, but I think that we should look to put some more energy into it in the coming months. Let's jump to data discovery. Some of you may be familiar with Amundsen. Amundsen's data discovery metadata engine. It basically reads the access logs, the logs from a database to generate sort of a PageRank style search based on usage patterns. In other words, like highly queried tables would show up earlier than less queried tables. And this is a pretty interesting project. And again, it serves the need of figuring out like which of these tables can I trust, are highly used, and in particular, how did that data get generated? So here in Amundsen, it actually has a native Airflow integration as well, where in Amundsen you can discover when you're looking at a table when was it last updated, and that's actually being read from Airflow metadata. And you can actually click the Airflow link here to go see the job run or the task that generated this schema. So it's pretty cool that that's all built in. Now, I've been trying to dig in to understand how the magic happens, and there's a little bit of work to be done for the reader to hook it all up. There's a basically there's a first generation way of doing it, and Lyft is kind of using a second generation idea, and we've kind of got a plan for a third generation that's on its way. But the other thing that's interesting about Amundsen related to Airflow is like basically Amundsen is scraping all these data sources. Again, the log systems for all these databases, and Airflow is traditionally used as the engine that's powering that scraper. So there's kind of two uses of Airflow inside the Amundsen product as it stands today. Yep. And then, finally, another idea here is open lineage. This is the same people that are working on Marquez are advocating for open lineage, which I find pretty interesting because, before, like, basically there's all these, Atlas, Marquez, Data Hub, Amundsen, this metadata challenge is interesting in the sense that, from Airflow, we need to get data to all these systems. From Spark, you want to get data to all these systems. From the databases themselves, from Hive and Presto, and that's a lot of lines in the middle. And so Open Lineage is trying to define a standard that each party can sort of program to and create an adapter of sorts, a USB universal adapter that'll allow data to easily get from a source to a destination with this lineage metadata in mind. So again, it's a very young project, but I think it has a lot of potential to solve. I think it's a necessary solution to really have lineage take off and make it easy for everyone to both create, produce, and consume the metadata. So let's jump over to what is Unravel doing related to Airflow observability. Gotten a chance to get to know the team a bit, and here's an example DAG that is in Airflow. It's just 4 steps, and it's basically running a Hive job and a Spark job, Hive and Spark, using 2 different methodologies. One's just a bash job, meaning command line is used to kick off the Hive. And the second example of Hive, it's actually using Airflow's built-in Hive operator. So they've basically built in a way to get the data from Airflow so that this sort of view is available inside of Unravel. You see, it's the same 4 tasks. This is the timeline, but it takes a bit of work to get a bit of magic to get the data to pass from Airflow to Unravel. And in this case, like, they're using a different technique than we use for Atlas, and a different technique than we use for Amundsen today. And like I said, I think that one of our goals from the Airflow side of the table is let's come up with a standard way to make this easier, because everybody's having to invent a hack of sorts. But what Unravel does, which I think is interesting, is they've implemented a little policy function that basically sends metadata from Airflow as params to the Hive and Spark commands, which then allows Unravel to link the jobs back to the original Airflow DAGs. That's only part of the equation. Like, they need to get these this data tagged with Airflow IDs, like I said, task IDs and job IDs. But they also need to go get the other metadata. So Unravel actually will scrape the front end of Airflow with the configuration, which is documented in their documents. And by default, it'll basically go 5 days back and just crawl the Airflow UI, to basically populate the database of everything that happened in Airflow. And then it's able to read the logs of the Hive jobs or Spark jobs to attach those things and put it all together for you inside their UI. So I think that's really cool. Future updates to this integration will leverage Airflow's new REST API, which was released in December 2020 with Airflow 2.0. Airflow now has a pretty robust and well-defined API that not only is available for consumption from other backend services, but the new Airflow UI will also consume it directly, and the Airflow CLI. So another one of Airflow's warts historically has been a lack of a official and strong API, but that's literally last year's problem. It's been solved, and we've got a great API now. So let's see. The other thing, I should mention is, inside of our platform, Astronomer, we actually have pretty interesting observability. So we provide, like I said, Airflow dial tone, but we let you see kind of deeper into what's going on than say a typical SaaS provider might. We let you see all the processes that are running. In a lot of cases, we're dealing with customers that were running Airflow themselves, and now that we're running it for them, and we just like to give lots of visibility into what's going on. So you can see the Airflow heartbeats. Because we have this view called task stream, which just kind of shows success and failures. You can see, the current database connection volumes. Luckily, no zombies killed. That's a fun stat, but that basically just means a process that hangs up for some reason. Python programs don't always finish the way they should, and so Airflow has a way to automatically prune that stuff. We also have, you can see how the CPU and memory of all the components are operating, including network transmission, both receiving and sending. So in addition to this is like the end user views of all that data, we actually have backend views for those that are running Astronomer in their own cluster. So in this case, we have a cluster that's running, has 309 Airflow deployments running that's been deployed to 37,000 times across all those deployments. And you can see things like, how many CPUs and are being used, and so on. So this is all powered via Kibana and Prometheus. And all the way down to the health of the schedulers over time, which is an important concept. What happens with Airflow is a lot of times, you have a certain number of DAGs running on a certain size cluster, and then someone deploys something new that's 10x perhaps what it used to be doing, and that can really put a strain on the current deployment if it's not set to auto scale. So this gives you a way to see all these metrics without having to program all this stuff yourself. So this comes out of the box with our enterprise product. I'd say another big challenge with Airflow itself is it's very database connection hungry. So every time you fan out and do lots of tasks, you have to, all those tasks might be accessing the database directly. And so we have a way to keep an eye on all that stuff. So we kind of just touched on a few of these observability metrics, and I went through it pretty quickly, but there's a ton of work to be done here. I think this is a great frontier, a very interesting space. We didn't talk about data schema or data downtime or data freshness, all that kind of stuff. Cost is another, to me, I think, really interesting domain, as well as task progress. I showed you a way you can kind of simulate that with DataBand, but we think that we should have an API that allows tasks to send progress reports into Airflow in a standardized way, which will make then observability of Airflow better for everybody. So that's, I should mention too, there's a lot of work, a lot of thinking being done around anomaly detection and so on, not only for the task run data, like a duration of a job. If you have something that takes, an extra long time, you should be alerted about that. But we really are focused in on now making sure that data, anomalies can be detected and tracked within Airflow as well. So that's all I've got in terms of the standard presentation. Looks like we have about 5 minutes left. If there's any questions, I'm happy to take them. I don't see any in the sidebar, which isn't necessarily a bad thing. But if you're listening and would like to ask a follow-up question to any of the content, I'm happy to take those questions. So I'll just give you guys a few minutes, or I should say 30 seconds to maybe type something in. Yep. Okay. So great question. Question on Airflow being versatile. What are the most popular use cases for Airflow in production? I would say that the most popular. Yeah, click answer live. See what that. Okay. So yeah, what that does. Historically, Airflow's been used for preparation of data for analytics. I would say. Airbnb used it early on to prep data for A/B test analysis. Was a big use case. It's being used though really for any job, any task that doesn't need to be real time. You can run Airflow schedules, every 10 minutes or so, but it's not going to be your solution for real time data. So if you're trying to update ETA, let's say DoorDash is trying to give you when the thing's going to show up, it's not the right use case. But if you're trying to basically reprogram an ML algorithm or retrain it based on new data for that ETA, it's actually a great use case. So I would say, you could take all of yesterday's data, crunch it, build a new model, deploy the new model, and you can orchestrate all that stuff with Airflow. So Airflow has a bash operator, so you can literally automate any command line. Any tool can be connected to this. So we have people use it to spin up infrastructure, run some Spark tasks, and then spin down the infrastructure at the end of that. So it's a way to save money versus leaving infrastructure that's only needed for a few hours up all the time. You can literally Terraform script something up and run all the tasks and then shut it down at the end. But ML would be another use case. Like I said, ML orchestration is as people are moving out of just theoretical and into real world production uses, you realize that the retraining of the data is a very important task and needs to be done on a very regular schedule. Cool. Let's see. I don't see any additional questions, and we have about 2 minutes left. So if there's any other questions, wait here, maybe we have a new one. Got it. All right. The question is, DAGs are also widely used in so-called Bayesian network algorithms. Have you seen any use cases in troubleshooting and remediation, et cetera? Yeah, I mean, DAGs are used, DAGs it's a fancy word for a very simple idea. I've not seen, in terms of troubleshooting and remediation, yes, there are people that use Airflow to automate data quality checks that maybe, again, it could be data that's flowing in real time from Kafka into Snowflake. If you want to check to see that the last 10 minutes data is what you expect, you could use Airflow to automate a troubleshooting check. Remediation, yes, you could take that result and then open up a support ticket, for example, automatically. One of the most popular operators we have in Airflow is the Slack operator. So lots of people have, reporting progress and any errors into a Slack channel, which is great. But there's also, tools where you can open up, a Zendesk ticket or anything like that. Cool. Well, thank you, everyone. I think we're out of time. It was great to chat. And if you have any questions for me afterwards, feel free to hit me up on Twitter or send me a LinkedIn request. Happy to talk. Thank you.